In the last class, we stopped in the third question. Find dou z by dou x if the equation yz minus log z is equal to x plus y defines z is equal to is a function of x and y. Right? So find f of dou z by dou x. In order to do this question, we have yz minus log z equal to x plus y. This is your first equation. Differentiate the whole equation with respect to x partially. See this. Dou by dou x of yz minus log z equal to dou by dou x of x plus y. So dou by dou x of y plus yz minus dou by dou x of log z equal to dou by dou x of x plus y means dou by dou x of x plus dou by dou x of y. This is dou by dou x of yz means y is a constant derivative of z with respect to x. So this is dou z by dou x. Minus dou by dou x of log z means this is a chain rule. So log z differentiation is 1 by z. Again the derivative of z with respect to x. Dou z by dou x equal to this becomes the ordinary derivative. This is 1 plus this is derivative of y with respect to x is 0. So dou z by dou x into y minus 1 by z equal to 1. So dou z by dou x equal to dou z by dou x into this is yz minus 1 divided by z is equal to 1, which implies dou z by dou x equal to this becomes z by yz minus 1. This is the answer. Right. Next one, a function of more than one two variable. Function of more than two variable. More than two variable. For example, if x, y and z are independent variables, independent variables, and f of x, y, z equal to x into sine of y plus 3z, x into sine of y plus 3z, then find dou f by dou z, dou f by dou z. So the solution is here the function is depends on the three variable x, y, z, not like in the previous case. So dou f by here, this is a f of x, y, z. So dou f by dou z equal to dou by dou z of x into sine y plus 3z, which is equal to x is constant dou by dou z of sine y plus 3z, which is equal to x into derivative of sine is cos y plus 3z into dou by dou z of y plus 3z, which is same as x into cos of y plus 3z into derivative of this is equal to derivative of y with respect to z is 0, derivative of 3z equal to 3 into derivative of z with respect to z, that is 1. So this is 3. So the answer is 3x cos y plus 3z. One more question. Next question. If the resistors of R1, R2, R3 ohms are connected in parallel to make an R ohm resistor, the value of R can be found from the equation 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Find the value of dou R by dou R2. If R1 equal to 30, R2 equal to 45, R3 equal to 90 ohms. And how will you solve this? Right? So here R is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. That means this R depends on the three variable R1, R2, R3. Okay. So we have to find dou R by dou R2. Dou R by dou R2. For that, this is dou R by dou R2 means I have the equation 1 in by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation. So I'm differentiating equation 1 with respect to R2 partially. What has happened? Minus 1 by R square into dou R by dou R2, which is equal to 1 by dou R2 of 1 by R2, which is equal to minus 1 by R2 square. So this is dou R by dou R2 equal to R square divided by R2 square. This is equal to R by R2 whole square. When R1 equal to 30, R2 equal to 45, R3 equal to 90, we can calculate this R from this equation 1 by R equal to 1 by 30 plus 1 by 45 plus 1 by 90, which is equal to this 90, 3 plus 2 plus 1. This is 6 by 90, which is equal to 1 by 15. So R equal to 15. So dou R by dou R2 equal to R equal to 15 by 45 whole square, which is equal to 1 by 3 whole square, which is equal to 1 by 9. Okay, this is a question. Next is a relationship between the continuity and the existence of partial derivative. What is the relation between the continuity and the partial derivative? So, is there any relation between these two? And we know that in the case of the one variable, derivative exists means that a function is differentiable means a function f of x is differentiable implies f of x is continuous. F of x is continuous. What the case of if f of xy, suppose f of xy, the partial derivative exists. Partial derivatives exist. Is it imply that it implies f of xy continuous? This is a question. is it implies f of x by continuous. So here there exist functions whose partial derivative exists, but it is not continuous. That is, the question is no. Is it implies that f of x is continuous? Answer is need not be. Need not be. For example, f of xy equal to 0 for xy not equal to 0, 1 if xy equal to 0. Please look through the textbook. You can see the graph of this example. Then from this, there are a partial derivative exists, but it is not continuous. Then what will be the condition for this continuity? Let's remark, if the partial derivative, if the partial derivatives exist and are continuous throughout a disk centered at x0, y0, then f is continuous at x0, y0.